And welcome to lesson 2.6, special functions. We're going to cover 3 types of special functions and how to graph them today. The first one is a piecewise function, or piecewise defined function. And the second one is absolute value function. Now, within the piecewise function, we're going to look at another special type of function called the greatest integer function. But in mathematics, there's very few things that remains constant over time. A case in point is right here. How many of you all have jobs? If you have jobs, then you pay taxes. Okay? Now, taxes are based on how much you make. The less you make, the less taxes you're going to have to pay. The more you make, the more you have to pay. Now, that all makes sense, but what you may not realize is that if you make a small amount of money, like part-time high school students and stuff, you make up to $7,825, you're only going to pay about 10% of your income in taxes, right? But on the other hand, if you make anywhere from $160,000 to $349,000, you're going to pay 33% of your income as taxes. These people right here at the low bracket pay $1 out of every 10 to taxes. The people in the high bracket pay $1 out of every 3 to taxes. All right? And that's why, this is called a piecewise function, because the function changes over time. So, I'm going to show you how to graph one of these today, and we'll just take it from there. All right, a piecewise function. It's going to look like this right here. Okay? Basically what it is more than one function. We have 2 functions here. I have f of x equals x minus 1. And then I have f of x equals negative 1. Can you graph those lines? Do you remember how to graph lines? No?
No, I'm thinking.
You can graph lines, yes. You can. It's possible. Watch this. All right, if I'm going to graph this first one right here, f of x, what's my y-intercept on this red equation? Negative 1. Okay? Y-intercept is negative 1. What is my slope? Yep, so my slope is 1, so I will go up 1 and over 1, 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 as much as I need to. I've got enough dots now that I can go through and get a line here, graph that one. Okay, let's see if I can get it right. That looks pretty dang good right there. You say so myself. All right, that's the red one. Now, could we graph the green one? Y equals negative 1. What would that graph look like? It would be a straight line. Well, they're all straight lines, but what you're thinking is it's going to be, in this case, horizontal. Okay? So f of x equals negative 1. Let me see here. I'm going to go and change that to a green line for my green line. Okay? All right. Negative 1. That was going to look like right about here. Okay, now that'd be all well and good, except each one of these functions is only good up to a certain point. And the key that you're looking for is right here. I like to call those break points. This is where one function stops and the other takes over. My break point in this one is 3, where x is 3. So what I want to look at now is my break point, and let's just say right here, 1, 2, 3. That's where these things are going to break. Okay? Now, notice your red function right here. This one, it says, is only good if x is less than or equal to 3. So, when I'm looking at this red function, it's only good up until I get to that break point right there. When I look at my green function, it's good beyond 3. So, when I go to my green function, this one takes over. Right? Now, one other thing that you need to pay attention to is here on your red function, notice you've got the less than equal sign, circle or dots. Would it be a circle for the less than equal or a dot? Remember, this sign right there, that's going to be a dot. If it were just this, it would just be a circle. All right, so I'm going to put a dot right here. Now, on the green one, where it takes over, greater than, circle or dot? Okay, so circle. Circle. Now, why is it important that we have circles and dots on this? Well, when we take a look at this dotted line right here, it's not really part of the graph. That's just kind of like the break point. That's what the graph looks like right there. Okay? If I run a vertical line test across this thing, if I had two dots, one above the other, would it be a function anymore? No, it would fail the vertical line test. Okay? All right. So, your key today is to find that break point on this and then to graph the lines. You know, this one's going to be on the left side. Whoa, what happened there? This one's on the left side and the green one's on the right side. You can use colors if you want to, whatever. All right? Now, oh, one other thing. When we're naming domain and range, all right, this is another biggie. Domain. Okay, think about your X numbers. Got my arrows. Important. Does this thing basically cover the entire X-axis? X, the domain, could be anything, could it? All right, so on this right here, my domain is all real numbers. Okay? Now, for my range, think about the Y numbers. Okay? Is there a part on the graph that is not ever going to be graphed? Yeah, you seeing it above this imaginary line right there? Do y'all see that? The graph will never go above that. It'll go below it, but it's never going to go above it. Okay? So for my range, since it's going to go below that dotted line, and that is at -2, I'm sorry, that's a +2, I say the range is Y such that Y, and this is less than, since it's a flow, less than or equal to 2. So your domain and your range. Questions there, ladies and gentlemen? Can you go? Who uses this besides Algebra 2 teachers? You'll find a lot of wizards using this. Let's see what else. Vikings use it a lot.
Oh my God.
Yeah, gods use it too. The Greek gods. All right, so there's a lot of people that use this. Here you go. Just a second, I'm recording now. All right, answer this very difficult question. I will hide the results. There we go. How old are you? Question.
Don't say it.
Still waiting on a couple of students. Still waiting on a count. But stopping the question. I say, stop the question. There we go. All right, insert the chart into the notebook. All right, here's the results of our poll in here.
18%.
All right, we've got 40% of you all are 16, 40% are 17, and then 9% are 18 or 15. All right, the whole point of this is that when I asked you all to answer your age, not one of you said 16 years, 7 months, 8 days. Did you? None of you said 18 years, 1 month, 20 days. You all gave a simple answer. How many years old are you? Now, this is not true because unless somebody has a birthday today, none of you are these exact ages. You see what I'm saying? Okay. This is an example of something that we call the greatest integer function. You've been using it all your life. You just didn't know that it had a name. The greatest integer function, let me get this moved out there. Come on, go down there. You all right? The greatest integer function is going to look like this when I make it, all right? F of x equals, and then you've got this weird looking bracket. and that's a new math symbol. All right? That's the greatest integer function. Now, how it works is very simple. If I'm asking for your age, all right, and if you told me you were 15 years, 7 months, and so on and so forth, I would answer 15. Okay? So that's what the greatest integer function does. If I have something like this, f of x equals, let's say, f of 1.5. 1.5 years old, what would the answer be? 1.5? And I ask your age, what would you say? I wouldn't use English words or language because you can't speak. Let's change it to 7.5. If you are 7 years, 6 months, how old are you? 7 years. Okay. What if you were f of 15.3? What would that be? 15. Okay, let's add a blank space here and I'll move on and we'll take a look at this. So, if my function is the greatest integer function, such as this, f of 1.5 would be what? 1. F of 2.3 would be 2. F of 7.1 would be 7. F of 0.8 would be 0. F of negative 1.6 would be, let's look at a number line. Okay. All right. 0, 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, negative 5. Okay. All right. You told me, and you were correct, that if I had f of 1.5, that would be 1. You're right. Okay. F of 2.3 would be somewhere right about here. You told me that it would be 2, and you were correct. F of 7.1 would be over here somewhere. You told me it would be 7, and you were correct. F of 0.8 is right about there. You told me that it would be 0, and you were correct. Now notice, you're always looking at the integer to the left of the point. Okay? So when I look at f of negative 1.6, 0, negative 1.6. What's that? Negative 2. Right. Okay. Remember, negatives work backwards. All right? Because you're looking to the left of the function. So if I have something like f of negative 3.8, that would be negative 4. All right? Okay, now when you're graphing these things, it's real simple. You just got to start off with, usually you'll start with a dot and draw it to a circle. Let's look at this situation right here. Okay, one psychologist charges for counseling sessions at a rate of $85 per hour or any fraction thereof. Draw a graph that represents this situation. So if you're in her office for 1 hour, how much are you going to pay? 85. If you're there for a half hour, how much are you going to pay? 85. If you're there for 15 minutes, how much are you going to pay? 85. All right? They have a certain fee that they charge. They only charge by hour, not a fraction. So, from the time that you get in there, if you're there at 0, obviously, you're not getting charged anything, so that would be a circle. Okay? But all the way up to that first hour, you would have a charge of $85. If you go past that first hour, even by 5 minutes, all right? And then another $85. And this process just continues on and on and on. Okay? Circle, dots. Circle, dots. Circle, dots. Circle, dot. What's that look like? Stairs. Okay? A more common name that we refer to this greatest integer function, a lot of times we just call this thing a step function. Okay? A step function, because it builds steps. All right? Okay, so when you're graphing these, it's also one of the things very important that you understand that in order for this to be a function and to pass the vertical line test, you cannot have two dots above each other. See? One has to be a circle and one has to be a dot if they're above each other. Otherwise, it's going to fail the vertical line test. Okay? So be sure that you do that when you're working through. Let's direct your attention here to problem number 5. It's on your worksheet. I recommend that we always make a chart. Okay, but keeping this chart, it's going to be a little bit different than what you have done in the past, where you always just do like a -1, a 0, 1, and 2, and so on. Okay? What I'm going to ask you to do here is let's look at a range of numbers. So from 0 to 1. Okay? From 1 to 2. From 2 to 3. From -1 to 0. All right, oh, that's wrong. That should be a -1. All right, now, let's go into the positives because they're easier to understand when you're making this. Now, first of all, let's say I've got 2.5. All right? What's 2.5 plus 1? 3.5. And what's the greatest integer you've passed? 3. So this would be 3. Let's go to the next one from -1 to 2. I'm sorry, from 1 to 2. Just think of a number, 1.8. 1.8 plus 1. 2.8. What's the greatest integer you've passed? 2. All right. And let's go here and let's just take a look at your zeros. 0.5. 0.5 plus 1. 1.5. What's the greatest integer you've passed? Okay. And you can see the pattern over here, can't you? 3, 2, 1. What would be here? And here? Okay, so once you've got your chart made up, then it's just a matter of putting stuff on the graph itself. So from -2 to -1 on your x-axis, right there's -2, there's -1. I need to have a dot, a circle, a line. Then just build your steps. A dot, a circle, a line, a dot, a circle, a line, a dot, a circle, line, and just keep this process going.
So that's how we started.
It goes all the way across. Questions? Yes, ma'am.
Where did we start at?
Where do you start it at? So you're talking about the graph itself?
Yes.
Once you see the pattern from these numbers, okay, you'll see a pattern on the graph. Continue that pattern, all right? Because it's going to build steps. The steps are going to have a certain length. Usually they're all about 1, but sometimes they could be longer. You'll see that happening after you've built it. And then once you've built, like for example, I started building mine at what point here did I start building mine? I started building mine at -2 to -1. So this was the first step that I built right there, okay? And I went up. When I saw the pattern, because I did this one, I did that one, that one, that one, then continued the pattern. All right? Step functions. Now, the last thing that we're going to cover is absolute value functions. They are piecewise in nature. All absolute value functions will look similar to this. What does that look like? A V. When you think absolute value, think V. All right? The thing that causes this to happen very simply is this. If I take and I make a chart of numbers, and I'm going to go through and do a whole bunch of them here so you can see what's happening. Make this chart of numbers where I've got my x and I've got my f of x. And let's just go from -4, -3, -2, -1, 0, 1, 2, 3, 4. And I'm looking at absolute value, okay? What is the absolute value of -4? 4. What is the absolute value of -3? What is the absolute value of -2? And -1, and 0, and 1. And see how it bounces back up? It went down, it started at 4, went down to 0, now it's going to go back up, and that's what causes that V shape. Basically, two lines. So you get this shape going down there, then it bounces, and then it goes back up there. Sir? These numbers right there, from my head. I just pulled them out of my head, okay? That's honest to God's truth. Okay? You know, it's the domain on these things are all real numbers. You can use any number you want to. I didn't go with like -4 million because I didn't have a graph big enough for that. Gotcha? All right. So let's take a look at this one here. This is, I believe, one of your problems on your paper. I think number 8, I think. Is that right?
Yeah.
Okay. So what you want to do on this is you want to build a table. Keep it simple. Whenever you're in doubt, build a table. X and fx. Indigo, give me some numbers. 7, 8, 9. Okay, well, this should be enough to get the pattern going, hopefully. Okay? If I use 7 for x, what's the absolute value of 7? 7 plus 1. If I use 8 for x, what's the absolute value of 8? 8 plus 1. And what do you think would be here for 9? Yeah. Now, once you get enough numbers there, you'll see a pattern. Let's throw these things on the graph. Okay? All right. So, 7 goes to 8. 1, 2, 3, 4, 5, 6, 7, 8. 7. 1, 2, 3, 4, 5, 6, 7, 8. All right, let's get another one. 8, 9. All right, 8, 9. 9, 10. Okay, Indigo. When you're picking numbers, you want to kind of go into the realm of negative numbers also. And the reason is because now I've got a line. I know this is absolute value, and all absolute values look like what? What do all absolute value graphs look like? They look like a V. This doesn't look like a V yet, does it? Okay? So I need to get some more numbers to where I can see where it's going to turn and go back up. Make sense? So, rather than choosing those numbers, if you went smaller, and went like -3, -2, -1, 0, and so on, what's the absolute value of -3? Plus 1. What's the absolute value of -2? What do I put here? And how about -1? And how about here? And let's go ahead and throw a 1 in there. What's the absolute value of 1? Do you see the turn? It's just happened now. We went from 4, 3, 2, 1, and started going back up to 2. So this is still going to be on the same graph that we started off with Indigo's numbers here, but -3 goes to 4. 1, 2, 3, 1, 2, 3, 4. -2 goes to 3. 1, 2, 3. -1 goes to 2. And 0 goes to 1, and then the turn happens again. And you can see what's going on there. Grab a line here. And it's going to be doing this to there. And this to there. And there's your V. And it's good to go. Questions?